Okay, another day and another concept tutorial. Today is going to be constants. And to save a little bit of time, I'm going to go ahead and copy and paste in the basics here. So we've got our IO stream, ConioH, and the namespace with the main program. And towards the end, eventually we're going to throw in the get and return. Alright, so let's implement our first constant here. So, and the number I am not going to type out because it's too long. So here is pi to many decimal places. So what constant is going to do is constants will fix the value. And to demonstrate, I'm going to go ahead and copy and paste a piece of cout code right here. Now, what's interesting about this is this backslash in front of the 6. It is needed to allow for that quote. This would do some simple math. Let's just go ahead and run it. And times 6, that looks about right. And it stops at the 4th place apparently here. Now, we question, what if we just get rid of that? Does it make a difference? Apparently not. So what's the whole point of that? And looking through the internet, there were a lot of intricate, extravagant examples. I didn't like those, so I'll just come up with a very simple way to demonstrate this. The concept to see to test the usefulness of constants. Of course, you don't need to have a capital. It can be lowercase or uppercase, but capitals is the convention for constants. So circle circumference, pi times 6, and L. So watch. What if we were to say pi equals 3? Expression cannot be modified because it was a constant, so it errors out. It won't let us do so. Now, if we were to knock out the constant, check that out. 18 because 3 times 6. It takes the latest pi value, even though we declared it up there before we even decided to call it 3. That is basically why constants are good. So let's just engrave that into our code. Next, I'm going to do something interesting. It's called enum. And let me go ahead and copy and paste a little bit of code here instead of typing it out. So red equals 1, yellow, green, black, brown. All of this is a bunch of constants being declared. 1 has a value of 1. This will have 2, 3, 4, because that's a property of enum. Enum will assign one integer value higher in a sequence of declared values. And let me get my cout statements to demonstrate. So red will be 1, blue is actually the 5th one out, so that's going to be 5. As a matter of fact, you can even see blue being 5 right there. And then 4, And it doesn't matter what number you do it. Like if you would do 3, it'll be 4, 5, 6, and then 7. So it adds 1. And this we'll do some basic math. So we'll get to that once we see it. Then next, actually for better flow, I should demonstrate it right now. 1 and 5, and adding it 6. Yep. So yeah. Next is something interesting. Negative, positive charge. Alright, charge is now a custom data type. And let me throw in some notes here. We'll call this custom data type charge. Basically, it will act the same as an enum. And let me go ahead and some more stuff in there. Just hang on a second here. Let me get it out. So we call it charge neutral equals negative and live equals positive. So we're just declaring a couple variables here. And we're just renaming those variables to be called neutral and live. But it's just a name. Let's do some cout statements here. Oh, I misspelled positive. Alright, quit the hate. Neutral wire will be neutral, and then that will be live. This has a value of 0. This has the value of 1. So let's just do an overview here. So this is just basic math. 1 because of our enum, and it's just pulling values out of our our list of constants. And apparently they're playing a game of bullseye or something. Right here, neutral wire 0, 1, because apparently it assumes an array that starts with 0. If you don't declare anything, it'll just be 0 apparently. Now we can screw around and prove that it's acting like an enum. Let's throw an LOL right there. Let's see what that does. 2. This is interchangeable. You can just call it positive and it'll still output 1. See? Now if we call it 1, this should be 1, that should be 2, that should be 3. 1, 2, 3. It works just like an enum, but we're calling it charge. So yeah, that's basically everything here. Cool.